All right, back with Mr. Newbold here. If you didn't make it on the day we did this lesson, then this video should help you. This is the Solving Rational Equations Day 1 homework assignment. And so basically they give us an equation and involving rational numbers and fractions, and they want us to solve for that letter. So for learning's sake, we'll jump to an easier one. And I did 1 and 2 in class, so you might need to do those ones on your own. But we'll try number 4 here, because that definitely looks like one that we could do that's not too hard to demonstrate for our first one. And so problem number 4, 1 over a squared equals 1 over a plus 5 over a squared. So we want to get a common denominator there. And so the common denominator that looks like, what's more complex to you, a squared or a? Which one is more complex? So you want to take that, the most complex one, the most complex term there, and you want to make the most complex or the more complex term your common denominator. I guess it's also called the least common denominator. And then we can do something quick and easy after we get that. That's probably the hardest part of these, actually. Okay. And so let's see here. So I think you got it right. It's a squared, right, is the most complex. And so that means we need to get this a over here, because we already have a squared there and a squared there. So we need this a right here. So to make it a squared, we times it by what it's missing, which is an a. But if you do it to the bottom, you also have to do it to the top. So now we have 1 over a squared is equal to 1, so that's going to be a now, over a squared plus 5 over a squared. Now to solve for a, we have all these a squareds in the bottom. That's not going to make it easy to solve, so why don't we just cancel them out? What? You can't do that, Newbold. I know, isn't that crazy? We can, and that's what's going to make this assignment fast and fun and easy. So I'll show you the math behind it. So we're going to end up with, just so you see for problem number 4, we're going to end up canceling those a squareds out and just having 1 equals a plus 5. Just solving the top. Just solving the top. And so how we solve the top is 2 minus 5 to the other side. And so we get a just equal to negative 4. Is that what you got? Yeah, so a just equals negative 4. And we should plug it back in and see if that works. I think it should, but we'll see. But the main thing now is to tell you why we can do that. Why can we just cancel the bottom off? Well, the reason why is we can do one thing is the same as the other. So let's say we have an equation or numbers, 5 equals 5, or 5a equals 5a. So can't we, to make sure they're equal to each other, here I'll give you another example there. What if you had 2a plus 5, or 2a plus 3a? Yeah, that still equals 5a. That's still true. Cool, so we can split that like that. But now I'm talking about multiplication. So could I times both sides by 2 is my question. Could I times both sides by 2? Let's see what happens. Well, 2 times 5 is 10a. And then 2 times 2 is 4a. And 2 times 3 is 6a. Does it still hold true? This is just an example off to the side, a separate example. Like, what is he doing? That doesn't make sense. No, I'm just doing a separate example separate there. So just to prove to you what we're about to do. So 4a plus 6a is 10a. 10a equals 10a. Yeah, we can do that. So we can multiply everything on both sides of the equation by something. And so why don't we make that something? Why don't we multiply the left-hand side by a squared, the denominator, over 1? And then we'll multiply the right-hand side with also with... Whoa, that's not what I wanted to move. Why don't I also go ahead and move, if it lets me. It's being weird right now. That's it. Why don't we go ahead and move that over a little bit there? Cool. And we'll bring that back to there. There we go. Okay. So if I multiply a squared over 1 to the left-hand side, why don't I also multiply a squared over 1? I have to do it to the left-hand side, do it to the right-hand side. And so when I do that, what's cool is that you're going to end up with an a squared here and an a squared here, and those are just going to cancel with the bottom a squareds, as well as this a squared with this a squared, right? Cool. So then all we're left with is just 1 equals, what's left here is a, and then plus, and then the a squareds went away there when we multiplied them through, when we distributed them through. And so we're just left with just a 5 there, yeah. And when we solve for that, minus 4 to the other side, we get a equals -4. Cool. So hopefully that makes sense. Okay, with number 3 now, so we have to get a common denominator. And so the lowest common denominator, because you could have 8 in the bottom everywhere, because they all go into 8. But really, 2 can just go into 4, and 4 can go into 4. So really, let's make them all 4. So how we can do that is by multiplying. At the top, and then also this one multiplying by 2 to the bottom and the top, so that we have 4 and 4v and 4. Now this 4, it needs a v, so we'll multiply v to the bottom and the top. Over here, multiply also, this needs a v, so how do we get that? Multiply it to the bottom and the top. And now that we have the all same common denominator, 4v, they can all eliminate, because you can technically multiply the whole thing by 4v is what you're doing, all the way across. And when you do that, it'll eliminate the 4 v's, right? So then our denominator is completely eliminated, and all we're left with is to solve the equation for v in the top. So 2 times 3 is 6v, plus 2 times v is 2v, then 2 times -3 is a -6 equals 3v. There we go. So then we're going to combine 6v and 2v is 8v. And then we have -6 is equal to 3v. We'll go ahead and minus the 3v, get all the v's on the same side. So we get 5v on this side. And we'll add 6 over to this side, so we'll get equals 6. And then we divide by 5, divide by 5. So we get v is equal to 6/5. And you plug it back in, 6/5. And you get like 12/5, which is not 0, which is fine. And you kind of do that everywhere, and it's going to work out just fine. So 6/5 is the correct answer for number 3. And here's number 18. So number 18. We need to get a common denominator, and so in order to do that, we have to factor this first. So we have x plus 1 and x minus 1 as the factors. And we want all the denominators. This is kind of going into day 2 solvings. This is really more advanced, really. But hopefully you gave it a try before you watch this video. I'm going to pause. I'm going to pause myself. Don't watch. Not yet. You got to do it yourself. Give it a try first. Pause me. Look at number 16 we did together. Okay, give it a try. Okay, so we got to get the same common denominator. So it already has an x minus 1, so we just need an x plus 1, right? So we multiply x plus 1 to the bottom and to the top. Good, so now we nearly have all the same common denominator. But that 1 doesn't have a common denominator of x plus 1 times x minus 1, so how do we make it have it? Well, you can turn 1 into 1 over 1, that's still 1. And then you can multiply x plus 1 times x minus 1 to the top and bottom, right? So you're going to have x plus 1 times x minus 1. Squeeze it in there. So you're going to multiply that with 1. Okay, and if you do to the top, you also do to the bottom. X plus 1 times x minus 1. And so, yeah, you can have anything over itself. And so now we can eliminate the bottom all the way across because they're all the same now. So then we get 2x times x is 2x squared. 2x times 1 is 2x plus just x minus 5. Didn't have to multiply that with anything because it already had the common denominator. X plus 1 times x minus 1. Then we're going to equals, and you know what, we already kind of know what x plus 1 times x minus 1 multiplied out is. It's x squared minus 1, right? So we're actually just going to write that down all multiplied out already. So x squared minus 1 goes there. Then we want to get everything on the same side and factor it to get 2 solutions. So we're going to minus x squared to both sides. So we get 2 minus 1 is just in 1, x squared. And then we have 2x and x is 3x. And then bring down the negative 5, but we're going to add 1 to the other side here. Oh, yeah, add 1 to the other side, so we get a minus 4. And then equals, those are both just 0. Cool, so now we just need to factor it. And it factors into x, and what, 1 and 4? With the positive 4 and the negative 1. Then, when you set both of those equal 0 and actually get your solution, solve for x, we add 1 to the other side, so we get x equals 1. X equals 1. And this one as well, but this time we're going to minus 4 to both sides, so we get x equals a negative 4. So those are two solutions for number 18. However, now, this is the tricky part we were saying. You got to plug it back in to see if it works. And when you plug 1 back in for x, you get up here, you get 1 minus 1 is 0, and you can't have 0 in the denominator because that's undefined. And so that's actually not a solution. Just x equals negative 4 is the solution to number 18. Or if you want to call it the extraneous solution, that's the proper term for it, because it is a solution, because we found a solution, but it's extraneous because it's because the exclusion is x can't equal x equal 1. So extraneous solution there. And there we go. Hopefully you enjoyed. Hopefully I put that funny roller skating bear in there, but maybe not. Ask me about it. But I'll see if I can put that in there when I get home tonight. Cool. Thanks for watching, and have a good weekend, or wherever you're at. Have a good night. Thanks. Oh, and finish this homework assignment. Thanks so much. You take care. Bye.